Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are in the fourth module where we are studying different milling machines. In the previous lectures, we have seen what is a milling machine and the types of milling machines. Now in this lecture, we are going to see different milling operations which can be performed on a machine. So, milling machine is a very versatile machine where different types of operations can be easily performed. So, very large components can be machined easily on a milling machine, which involves various types of operations. So, some of the operations are which we are going to discuss now. There are about 14 processes which are going to be discussed in this lecture and the coming lectures respectively. All these milling operations which are suitable for some kind of application. Some type of applications required a particular process. So, the first one, there are about 14 processes. First one is plane or slab milling machine or face milling, and then angular milling, straddle milling, slot and groove milling, slitting or saw milling, end milling, gear, form, gang, keyway, side milling, profile, and thread milling. These are the different types of milling processes that are possible on multiple milling machines. These are all processes not all possible on a single milling machine. Some milling machines have some properties, like they have some of these machining techniques. Okay. Now let us see the first one. We have to see everything in detail. So, the first machining process, first milling process that is possible is plane or slab milling. So let us see what is plane or slab milling. So plane milling is used for machining a flat, plane, horizontal surface parallel to the axis of cutter with the help of plane or slab milling cutter. We can see in this picture, this is the workpiece and this is the tool. So this is a multi-point cutting tool, whereas it is rotating on its axis, about this axis it is rotating, where when it is come in contact with the workpiece, it can remove metal. So this kind of milling process is called plane milling, a simple type of milling process. This is also called as a slab milling because it is used for flat horizontal surfaces. So we can attain flat or horizontal surfaces very easily with the help of this plane milling. Okay. For machining of a very wide surface interlocking teeth, plane milling cutters are used instead of simple plane milling cutters. So if we want to machine very wide surfaces, that means more width of the workpiece is there, then you have to go for other type of milling machines. And also if interlocking teeth are there on the milling machine, so then the milling cutter should be replaced with a simple plane. Okay, we have to use plane milling cutters for getting better milling on the more width surfaces. Okay, during the operation, the workpiece and cutter are secured properly on the machine, and by rotating the vertical feed screw of the table and machine, the depth of the cut is adjusted. So, whenever we are doing the milling operation on a particular workpiece, we have to see that the workpiece and cutter means the tool, both of them are properly securely aligned. Okay, so that while rotating at higher speeds, the tool should not come out of the spindle or the workpiece, and the tool should not collide with each other so that vibrations are formed. Sometimes the tool may be broken or the workpiece itself is damaged, etc. So we have to make sure that both the tool and the workpiece, both of them are secured properly. So the machine, by rotating vertical feed screw of the table and machine, the depth of the cut is adjusted. We can adjust the depth of the depth or the feed of the cut by adjusting the vertical feed screw. So this is a simple type of milling machine or milling process where we can do milling for flat, plain, horizontal surfaces. Okay, and then we have second type of milling process. This is face milling. So if I have a object, suppose I take the example of a cylindrical bar. So this is a cylindrical bar where I have to reduce the length of this bar. This is the length. So if I want to reduce the length of this bar, I have to keep this workpiece in the bench wise or the machine wise on the table, and then I have to keep it in a direction such that its cross section is located here. So this is the workpiece. So this is the cylindrical workpiece. Okay. So the cylindrical workpiece is placed like this. It has to be aligned in this direction so that the upper part, the cross-sectional face will be towards the top side. That is towards the tool. Okay, where I can fix the tool in the vise and I can bring the tool near the workpiece, and the workpiece face will be milled. Okay, so face milling is employed for machining flat surface which is at right angle. So for getting the flat surfaces, we have to use this face milling, which is perpendicular to the rotation of the tool. Okay, rotation of the revolving cutter. The cutter used in this process is called face milling type, which is rotated about an axis perpendicular to the workpiece. Okay, this is the axis of rotation, and the face of machining is perpendicular to this axis of rotation. Because we know from the diagram we can simply see this is the surface which is being faced. This is facing, and this is the axis. Both are perpendicular to each other. The operation is performed on plain milling machine, and depth of cut is adjusted by rotating the cross feed screw of the table. Okay, whenever we want to do this operation, the operation is performed on plain milling machine. Okay, so this face milling is possible on plain milling machine. We have seen all the different types of milling machines in the previous lectures, and this is possible on plain milling machine, and depth of cut is adjusted by rotating the cross feed below the table. Okay, we have a cross feed screw by which we can adjust the depth of cut. Okay, we can lift the table or we can lower the table by moving the screw. The screw is called adjustable screw, which is below the table. Okay, cross feed screw. And then face mills under 150 mm are called as shell mills and are held on the shorter arbor. If the face mills are less than this value, 150 mm, the size of the cutter is less than 150 mm, then they could be called as shell mills, and they are held in short arbor. So arbor should be in a smaller size. So the workpiece is very small in here. Okay, so that is why the tool is also very small. And then let us move to the next type of milling process. This is angular milling. So here we can see in the picture, the angular milling tool is attached to the spindle which is rotating, and the workpiece is placed below it. Okay, here we will get the shape of the milling. See here, the shape of the milling tool is like this. It is in the V shape. So same kind of grooves can be seen. See here, we can get a similar type of groove on the workpiece. Okay, so angular milling is used for machining a flat surface at an angle. So we can get required angle in this process. Okay, so this angle can be obtained. For example, V blocks according to the type of surface, the single or double angle cutters may be used. So depending on the type of angle or inclination we need on the workpiece, we can actually change, or we can actually cut the workpiece in the required V shape. So the tool itself is in the inclined manner. It is in the V shape. It will give a V shape onto the workpiece also when it is in contact with the workpiece. Okay. So this is angular milling, where we can get inclined surfaces. So we can convert the flat surface into inclined surface. And the next type of milling process is form milling. So what is form milling? Form milling is the operation of machining irregular contours by means of a form milling cutter. So we can get irregular contours. Whether so far we have used some kind of machines which are possible, which makes the process of regular shapes. Okay, we have regular process making machines, but if we want to get some irregular shapes, then we should go for form milling. So what's the key difference between regular type of millings and this form milling? The only difference is we can get irregular contours. Any irregular shapes can be machined on this form milling machine. So the irregular contours may be concave, convex, or any other shape. So any other shapes like concave or convex shapes, other than these shapes, we can get any curved shapes. So they can be easily milled by using form milling. So the cutting speed of form milling is 20 to 30% less than that of plain milling. So we have seen the first process, that is plain milling, and the speed of this form milling process is 20 to 30% of the plain milling. Because why it is so slow? Because we have to do this contour shaping very slowly, because it is not a regular shape. In the previous form, we can see this is a V-shaped cut. So this is called angular milling. A certain angle is given to the workpiece when it is machined. But here, we don't have a particular shape. We have to go manually, or we have to depend on the tool to give a particular shape. Or sometimes we have to use the tool which is available, but we have to create a own irregular contour which is of our requirement. So for that we need practice and more precision is required. So that is why the speed of this process is only 20 to 30% of the plain milling. So this process is very slow when compared to other milling operations. Why this has to be so slow is that we have to make irregular shapes. The shapes are not standard shapes like plane, horizontal, uh, angular shapes are not. So these are irregular contours which are to be milled with precision, and this needs high skill. And then the fifth type of milling process is straddle milling. So straddling milling is the operation of a flat vertical surface on the both sides of the workpiece simultaneously. So this is we can call this as multiple tool milling process, because we have more than one milling tool is present here. So we have a single arbor, which is nothing but a shaft on which we can attach multiple tools, and these multiple tools, generally a single tool will have a multiple cutting edges, but in this process we have more than one number of tools. We have two tools here, 1 and 2. So these two tools which will cut the surface, which will cut the workpiece simultaneously. Okay, it will cut the workpiece simultaneously. This is only suitable for a limited number of applications because of its constraints. It has some limitations. Why? Because these two cutters, they has to be adjusted only up to a certain limit. The length of the adjustment is not very large because they have to act within the length of the spindle only. If the spindle is about this length, it can go up to the extreme edges of the spindle, or it can go as close as the togetherness of the cutters. Okay, so these are some limitations, and this is only applicable in some particular type of applications. Okay, so this is a straddle milling. So straddle milling is the process where we can cut two sides of the workpiece simultaneously. For this purpose, two-side milling cutters are mounted on the same arbor. So the same arbor will carry the two cutters. For this purpose, by using suitable spacing collars, the distance between the two cutters can be adjusted. So by using some kind of collar. So here we have a separate metallic rod arranged between the two cutters, which will maintain the actual distance between the two cutters. Okay, the two cutters should be placed at a required distance with the help of a collar. The collar will be placed between the two cutters. This process is mainly used for the production of square and hexagonal shapes only. Okay, so this is not suitable for everything. So this is suitable for only hexagonal surfaces and square surfaces. So these are the applications of the straddle milling process. Okay, and then we have gang milling. So what is gang milling? So gang milling is also another important process which is required for most of the engineering applications. So gang milling is the operation of machining several surfaces of the workpiece simultaneously. Suppose I have a workpiece. This workpiece is a cube. So the cube, it has many faces, like about 6 faces are there. But I cannot I cannot make surface finishing on all surfaces. Okay, I cannot work on multiple faces in general machines. But in gang milling, I can work up to 3 faces, like 1, 2, 3, and 4. All the 4 faces I can work simultaneously based on the type of configuration that is available for the machine. Okay, so all the 4 faces I can work simultaneously. All the 4 faces can be machined parallelly. That is why a group of faces or group of operations are done on a single workpiece. That is why this process is called gang milling operation. So gang milling is a set of operation or a machining process which is done on the workpiece simultaneously. For this, the table is fed against the number of cutters. Okay, the table is fed against number of cutters. Multiple cutters will be there. As in this case, we can see this picture. We have 3 cutting tools here. 1, 2, and 3. There are 3 cutting tools, and this is the workpiece. And this workpiece is being machined by 3 cutters. We can see clearly here. The first cutter is cutting this surface, and the second one is cutting a center hole at the top of the workpiece, and the third one is working here. Okay, so 1, 2, 3. 3 cutters are working simultaneously on the same workpiece so that multiple operations can be done on a single milling machine. So this is a very good milling machine as in the perspective of engineering application. So gang milling is very widely used because they can do multiple operations by simply changing the arrangement of the gear of the cutters and workpiece. We can actually do multiple operations on the workpiece at the same time. So for this, the table is fed against the number of cutters having same or different diameters mounted on a common arbor. So all the 3 cutters, they are mounted on a common arbor. This method saves machining time and is widely used in repetitive work. In most of the manufacturing industries, like we take the example of a manufacturing industry which produces large amount of nuts and bolts. They will produce these nuts or bolts at a larger rate. Because they are very small in size, they will be manufactured at a very faster rate. Then this type of gang milling is very useful because we can save the work time. The production time can be reduced. So if doing separately, if suppose there are 3 processes that are to be done on a mechanical element, all the 3 processes will take about 5 minutes, 5 minutes and 5 minutes. So totally I will take 15 minutes to complete one workpiece. So when I come to gang milling, I can save 10 minutes of time because I will arrange all the 3 processes into a single machine and I will reduce the time. Okay. So I will reduce the time by 10 minutes. Okay. So I will remove the 10 minutes. Only in 5 minutes of time, I can complete all the 3 processes because all the 3 cutting tools are arranged onto the same, what we called, they are arranged on the same arbor. Okay. Same arbor is there. On the same arbor, we can attach 3 tools and 3 tools will work simultaneously. Okay. Although this is not possible for every application, like every machining process cannot be done like this. In most of the cases where multiple cutting tools can work at the same time, then this process is very useful because we can reduce the working time. Maybe 1/3 of the working time may be reduced. So that is why the gang milling process is one of the very interesting application in the milling process. So far we have seen 6 different types of milling processes. That is plain or slab milling. Then we have face milling, angular milling, form milling, straddle milling, gang milling, and we are going to see different other milling processes in the coming lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.